Hello again, students, and in this lecture I am going to discuss just basic information about lipids. For a change, why don't you pause this recording and read the objectives instead of me actually reciting them, okay? The bulk of lipids that we ingest with foods, we ingest as triglycerides. As you can see, triglycerides are composed of one molecule of glycerol to which 3 different amino acids are attached, okay? One of the functions of lipids, the reason why they are important in the body is because they are used for energy. For example, even athletes, as they engage in physical activity, in the beginning of their activity, about 50% or so of the energy that they use is actually derived from using triglycerides. Only as the activity progresses, they will use more carbohydrates versus lipids. But we need energy from lipids also on a daily basis, regardless of whether or not we are engaged in physical activity. Second class of lipids are phospholipids. In phospholipids, we have a molecule of glycerol, 2 fatty acids attached, and then something we call a phosphate group, okay? And phospholipids are essential actually not only in the body, but also in food processing, food manufacturing. But in the body, they are essential to maintain cell structure. They are found in the cell walls and in the walls of the different organelles, such as the nucleus and mitochondria and other organelles in the body, okay? And then we have sterols which look different. They are not composed of glycerol. They don't have fatty acid attached. They are composed of what we call a ring structure-like type of formation. And you have an illustration of each of these triglycerides, phospholipids, and sterols in the course pack, okay? Again, sterols, as was the case with phospholipids, are found in the membranes of a cell structure. But more importantly here, I listed that they are important for the synthesis of hormones, including vitamin D, for example. We have cholesterol under the skin. When we are exposed to the sun, that cholesterol is converted into vitamin D. We will be learning about this later on this semester, okay? And these hormones actually include also sex hormones, including estrogen and testosterone, for example. Here we have a structure of a molecule. What does this structure represent? Well, I just talked to you about glycerol. Here we have a glycerol structure to which 3 fatty acids were attached, and that's the case for triglycerides. Tri represents or indicates 3 fatty acids attached, okay? Now, if only 2 fatty acids were attached and there was something different here, it would likely be what? Phospholipids, okay? How about this structure? What does this structure represent? When this is what we call a bilayer. Bilayer is a typical feature of any cell's wall, okay? The cells are surrounded by a wall, and a bilayer, lipid bilayer, is the integral part of the wall. Notice that lipids, as you learned from the course pack reading, have hydrophobic and hydrophilic part, okay? And so the hydrophobic part you can see here represented by what we call a head, and hydrophobic part represented by tails. And this specific structure is absolutely essential for the cell to function in a water-based environment, okay? Fatty acids, which are the basic components of lipids, are divided into saturated, monounsaturated, and polyunsaturated. This is based on a chemical structure, and I will show you in a moment the illustration. And again, you had the illustration also in the course book. Okay. Now we have several different fatty acids listed, and I don't want you to necessarily memorize all of them, but please do remember that stearic acid, actually this is the most abundant saturated fat in the diet. Oleic acid is the predominant source of monounsaturated fat. And then in the polyunsaturated fatty acids category, we recognize two different groups or categories. The omega-3, sometimes in the textbooks and in the different scientific manuscripts, they are simply designated as N3 and omega-3. Okay, I want you to be familiar with all of these. Alpha-linolenic acid, this is the parent fatty acid from the omega-3 long-chain polyunsaturated fatty acid. Eicosapentaenoic acid, if you just simply remember EPA, and docosahexaenoic acid, if you remember DHA, you are in good shape. Okay, these three are from the omega-3 family. And then we have two listed for the omega-6 family. There are more for both of these categories, but I just listed these two for omega-3 and 3 for omega-3. Linoleic acid is the parent amino acid, and then arachidonic acid is another example for omega-3. The reason why I call alpha-linolenic acid and linoleic acid parent fatty acids is because once we have these parent fatty acids, at least theoretically, we can actually synthesize the other fatty acids in the omega-3 and omega-6 family fatty acids. We also categorize fatty acids based on whether they are short chain, medium chain, or long chain. Again, in a moment, I'm going to show you that fatty acids are a chain of carbons. So if they have few carbons, notice up to 6 carbons, they will be in the short chain fatty acid category. When they are between 8 and 12, they are in the medium, and then 14 to 22, they are in the long chain fatty acids family. Let's look at the chemical structure at this point of time. Here we have it. We have a chain, notice, of carbons to which hydrogens, okay, and here, notice, oxygen are attached, okay. We have a metal group on one end and a carboxyl or acid group on another end. And we have here a few examples. Alpha-linolenic acid, which is again the parent fatty acid from the omega-3 family. The reason why this one is called or is classified as the omega-3 is because notice when we count from the omega carbon, this carbon is called the omega carbon. Notice 1, 2, 3rd. On the third carbon, or between third and fourth carbon, we have a double bond. And we have the double bond because the chemists tell us that carbons always have to have 4 different bonds. And since we have hydrogens missing in this structure, these carbons form a double bond. And since the first double bond is formed between the third and fourth carbon, this is the omega-3 family. Linoleic acid, on the other hand, notice 1, 2, 3, 4, 5, 6. The double bond begins with the 6th carbon, and this is why it is in the omega-6 family of fatty acids. And this structure also has the metal group and the acid group here. Stearic acid, as I already mentioned, is saturated. Saturated means that there are no double bonds in its structure. All carbons have as many hydrogens attached to a saturated fat as it is chemically possible. Okay, so This is why the alpha-linolenic acid is polyunsaturated, the linoleic acid is polyunsaturated, stearic acid is saturated. If we had here a monounsaturated fatty acid such as oleic acid, we would only have one double bond, but we don't. I don't have that illustration. Remember, any fatty acids with at least two double bonds, or two, we call it points of unsaturation, represented by the double bonds, would be in the polyunsaturated fatty acid category. Again, we have highlighted these double bonds here on the third and sixth carbon in the structure. These carbons are called the omega carbons, and again, counting from the omega carbon, we have omega 3, omega 6. Okay, here just an exercise for you. Would you name this? Look at this structure, pause my recording. Would you be able to name this? Okay, let us now look at the dietary sources of fatty acids. We are going to begin with trans fatty acids. Before we get into the actual sources, let me say that in the United States, adding trans fats to foods is no longer permitted. The Food and Drug Administration issued a ban. So the sources that are listed here were the predominant sources prior to making that ban. I am still showing you the sources because in many countries trans fatty acids are still used, and likely the sources constitute the main sources of them in those countries. So when you see here the average daily trans fat intake in the US is almost 6 grams, which constitutes 2.6% of calories. Again, that was prior to banning. Okay, in China, you have here much lower intake, which is actually advisable. So what were the main sources? You can see here cookies, cakes, crackers, pies, bread, candies, and then animal products and margarine, and some of the others are naturally containing trans fatty acids. But those that were added to foods, artificial trans fats, the main sources are the junk food, like cakes and cookies and crackers and things of that nature, okay? On this slide, I listed several significant sources of saturated fatty acids. Notice the very first one is hydrogenated soybean oil. Now, soybean oil, naturally speaking, is actually polyunsaturated mainly. However, in the process of hydrogenation, or I should say, the process of hydrogenation means making unsaturated fatty acids saturated, okay? And so anytime we ingest hydrogenated soybean oil, partially hydrogenated soybean oil, we are ingesting trans fatty acids which contain artificially made saturated fatty acids. Then coconut oil, shortenings, butter, and palm oil. And notice that we have here both plant sources, hydrogenated soybean oil, coconut oil, palm oil, as well as animal sources, butter, lard, and bacon. Now, when we look at the food items that we actually ingest, we find that mixed dishes, which means burgers and sandwiches, okay, for example, constitute the biggest source of saturated fat, burgers and sandwiches. And so these, if you want to improve intake of saturated fatty acid, improvement here meaning a reduced intake, we should focus on these particular food sources. Okay, here I listed sources of monounsaturated fatty acids. They include olive oil, canola oil, peanut oil, okay, and then nuts, pecans, peanuts, almonds, cashews, and avocado. Other nuts as well, but these are just the few I listed. Avocado is a relatively good source also of monounsaturated fatty acid. When we look at specifically nuts, notice that the most of them include mainly monounsaturated fatty acids. There are a couple of examples, or a couple of exceptions, I should say. Pine nuts as well as walnuts mainly include polyunsaturated fatty acids. Regardless, we should consume a variety of different nuts, okay? Not just one type, but a variety of different nuts. Both the mono and polyunsaturated here have some beneficial health effect. How about other sources of polyunsaturated fatty acids? Well, for omega-3, we have flaxseed oil, flax seeds, chia seeds, and fish oil supplements. And then for vegetable sources, we have refined oils. So soybean oil, sunflower seeds oil, any refined oil, along with salad dressings.